Hi there, my name's Jeff and this is Thinking Math, and welcome to my video series on exponent laws. The first video we're going to look at today looks at the multiplication law, which states the following. A to the m times a to the n equals a to the m plus n. Now before you dive into this, I'm going to bring up thinking principle number 8, which says you learn the language of math itself. So here I have a to the m, which tells me it's an exponent. I'm multiplying another exponent, a to the n. Now this law only holds true if I'm multiplying. I can't have division, addition, or subtraction. So that's the first one. Seems like it's a moot point, but it does make a difference. And the second point I want to highlight is I use a in both of these variables. That tells me that no matter what number I substitute in for a, whatever I substitute in for this a, it has to be the exact same number as this a. So if it was 5 cubed here, this has to be an exponent with a base of 5 as well to make the law work. And then when you see that this is the case, you leave the base the same and add the exponents. Here's a couple examples to prove this law. Now I like to use numerical examples when I can to start off a law to show you that laws remain true no matter what you put into them. That's what's nice about math. It's the same every time. So for instance, if I had 8 times 4, we know that's 32, but I could rewrite 8 as a base of 2. 2 cubed, and then 4 can be written as 2 squared. Now, according to my law, I have the same basis and I'm multiplying two exponents. I just have to add them together. So I get 2 to the 3 plus 2 is 2 to the 5. And if you multiply 2 to the 5 out, it's the exact same answer as 32. So I use numbers to prove a principle. And that's a very good skill to have for when you get to SAT preps. Some questions on the exam, you can even just try numbers or try submitting numbers into variables and see if the law holds true. And if it isn't, you generally have your answer. Let's take a look at a few more examples here. Okay, the first example is a really standard basic example. It's x to the 7th times x to the 3. If you're wondering why I put a dot there, we can represent multiplication as a dot. Because with variables of x, you can get confused with the multiplication sign and x's. So now that that's understood, I have two exponents with the same basis. According to my law, I can just add the exponents together, and I get an answer of x to the 10. Now I'm going to bring up thinking principle number 3 here that says focus on the concept regardless of the numbers being used. Okay, oftentimes textbooks will increase the complexity by changing what the numbers look like, but if students still remain true to their laws, it's actually not that difficult of a problem. Here's what I mean. If I had b to the 1/4 times b to the 1/2, some students might look at that and say fractional exponents, oh, that changes things entirely. Well, no, it doesn't. I'm multiplying two exponents with the same base, and if that's the case, my law says I just have to add the exponents. Sure, the addition is a bit differently because now I'm adding fractions, I need common denominators. So I get a common denominator by multiplying the top and bottom by 2 here. And I get b to the 1/4 plus 2/4. And that gives me an answer of b to the 3/4. Okay? Next example has negatives. The law doesn't change though. All right, for this final example of this video here, I have c to the -2 times c to the -4. Now, again, I have negatives. Some students panic and I'm saying don't. The law simply states if I'm multiplying two exponents with the same basis, I just have to add the exponents together. Now, yes, this situation is differently because now I have integers in my exponents. If you need a quick refresher on integers, what I tell my students, if there's an addition and subtraction sign side by side, I like to clean it up. And because there's an addition and subtraction sign side to side, I can just drop off the addition sign entirely. So I have c to the -2 minus 4, and when I have negatives, I often tell students it's like debt. Positive is money you have, negative is money you owe. So here, I owe $2, and then I owe another $4, therefore I'm owing $6. Another quick way of looking at it, if both numbers are negative, I add the numbers together and just place a negative sign in front. That's all there is to the multiplication law. Tune in to my next video on the division law.